Hello, today in this video we will solve pair of ordinary differential equation using Laplace transform. So before you see examples of solving a single differential equation, if you have a pair of differential equation, how you can solve these equations. So for example, if there are two equations, this is y1 dot equal to minus 8 by 100, y1 plus 2 divided by 100, y2 plus 6. This is the initial value problem. Similarly, we have y2 dot here. So these are two first order differential equations, and these are non-homogeneous equation, as you see 6 here. So initial condition given are for y1 0 is 0 and y2 is 150. As this is first order, so I need two differential equation initial conditions to solve this differential equations. So first step is to apply the Laplace transform and rearrange the equation. When I apply the Laplace transform with the initial condition, I come up with these two equations after simplification in terms of y1 and y2. So if you look here, I write these in terms of, we have a right side here and we have a left side. So at the left side I write equation in terms of y1 and y2. So now the thing is, I have to find y1 and y2. Okay, so for doing this, the next step we apply is to solve using Cramer's rule. Now Cramer's rules, first we have to make a D matrix, and that matrix is based on these two equations. So I write the coefficient of y1 here, similarly coefficient of y2 here on the left side of the equation in equation 1. Similarly in equation 2, coefficient of y1 here, similarly coefficient of 2. So this becomes a D matrix. So if I go back, look here, if I go back to my equation, this one, look here, now this is the first this is the coefficient of y1 here, this is y2, similarly this is for y2 and y1 in second equation. So this is the right hand side. So now I have to make for, if I want to solve y1, I need another matrix that I called it as d1. So how I made d1, I just remove the first column and replace with the right hand side, that is minus 6 by s and minus 1 by 50. So I just plug in these values here, so this become d1. So look here, I just replace the first column here. Similarly for d2, to solve the y2, I replace the second column. So look here, second column is replaced by this right hand side. So these are two matrices which I need to solve for using Cramer's rule. Now if I go back, so how I solve these equations, first of all I need to take the determinant. So I take the determinant of D matrix, D1 matrix and D2 matrix. After that I need to take a ratio of y1 of s, that is d1 determinant divided by d determinant. So it becomes this equation. Similarly for y2 is d2 divided by d determinant. So these two equations. Now the problem is that I need a solution in time. So this solution is in s, okay, or s plane or in frequency domain. So I need to convert this back into time domain. So to do this I need to use the Laplace table. Now the problem is that these type of formulation is not available in Laplace table. So there are some tables. In table we have some relation, but we need to convert these two in that relation. So for that case I come up to the third part, and that is partial fraction. So I need to solve using partial fraction. So what is partial fraction? So I have to convert this into a fraction of 1 by s plus 2. So this becomes a partial fraction. Similarly for y2, when I do this thing, now it's very easy. Now I have to use the table and compare from the table. As I know that anything divided by s is represented by step response, that is 1. So I just wrote that y of t in time domain is equal to 100 minus, if something is divided by s plus 0.12, so it can be represented that the numerator times exponential minus this coefficient, that is 0.12. Similarly for the last one we have to do the same thing. So look here, for y1 and y2 I get this 100 minus 62.5, this the exponential, similar this. So similarly for y2. Now one thing you have to remember, that denominator in both cases are same. So this means that the coefficient values with the exponential must be same in both cases. So look here, exponential minus 1 to 41 is also present in y1 and similarly for y2. So this is the match that you are doing correctly or not. So this is all for solving pair of ordinary differential equations using Laplace transform. Thank you.